This is our second lecture in the elasticity series. This one's going to focus more on the math of calculating elasticities. Remember this table that we saw. Last time we said if the percentage change in quantity is greater than the percentage change in price, we'll get an elasticity computed that's greater than 1, and we'll call it elastic. If the opposite is true, it's inelastic, and if those changes are equal, it's unit elastic. Now let's talk a little bit about how we're going to calculate those elasticities. Our midpoint elasticity approach is going to take a change in quantity and divide it by the average of the two endpoints in quantity. Similarly, we'll take the change in price, and instead of dividing it by the starting or ending price, we'll divide by the average of those prices. This is handy for complicated mathematical reasons that mainly involve making sure that we get the same elasticity whether we start at the lower price and raise it, or start at the higher price and decrease it. There are basically 3 steps to calculating an elasticity. 1. Recall the formula. Percent change in quantity divided by percent change in price. 2. Rewrite the formula in midpoint form. Percent change in quantity is Q2 minus Q1 over Q2 plus Q1 divided by 2. That times 100 is going to come off at the end, so we can ignore it for now. And then we'll take our percent change in price and replace it with P2 minus P1 over P2 plus P1 divided by 2. Again, we can chop off that times 100 because there's one upstairs, there's one downstairs, they're going to cancel out. And finally, we're going to take those the price and quantity values and determine the elasticity by plugging and chugging. Let's do an example. The information we're given here is that the price of widgets rises from 198 to 202. That means our P1 is going to be 198, our P2 is going to be 202. The quantity of widgets that buyers demand falls from 51 to 49, so our Q1 is going to be 51 and our Q2 is going to be 49. We want the price elasticity of demand for widgets. I've reproduced the steps to calculate the price elasticity of demand, but let's work our way through them. Take a moment, make sure you have these steps down. Ready to move on? Okay, so step 1. Use the price elasticity of demand formula. Percent change in quantity divided by percent change in price. Then, we'll use the midpoint method to rewrite the percent change in quantity as Q2 minus Q1 over Q1 plus Q2 divided by 2, and percent change in price as P2 minus P1 over P1 plus P2 divided by 2. Let's put that into action. Our elasticity formula is Q2 minus Q1 over Q1 plus Q2 divided by 2. Since our Q2 is 49, that's our second quantity, and our Q1 is 51, we can rewrite the bottom as 49 minus 51. We can also rewrite the denominator of that top fraction as Q1 plus Q2 divided by 2 as 51 plus 49 divided by 2. Our initial price was 198, and our new price is 202. So the denominator will begin with 202 minus 198, and then downstairs we'll need 198 plus 202 divided by 2. So now we can use those values and simplify. I've reproduced the equation we had on the previous page here, and now let's take some steps. Let's take 49 minus 51, that's going to be negative 2. 51 plus 49 divided by 2, that's going to be 100 over 2. 202 minus 198 is 4. 198 plus 202 is 400. So our next step is going to be to simplify that equation into negative 2 over 100 divided by 2, all over 4 over 400 divided by 2. Let's take that 100 divided by 2 and turn it into a 50, and that 400 divided by 2 and turn it into a 200. So now we have negative 2 over 50 divided by 4 over 200. And then let's just go ahead and simplify those. Let's pull a 2 out of the top and a 4 out of the bottom to get negative 1/25 upstairs over 1/50 downstairs. Now, there is a little bit of a trick here. Some of you might be looking at this going, I don't remember how to divide fractions. Fortunately, there is a song you can use to remember this. That is Missy Elliott's Work It. Put your thing down, flip it, and reverse it. So we're going to use the Missy Elliott method. We're going to put our thing down, that's our numerator, just leave that as it is. So we'll write negative 1/25. Flip it, that's our denominator. Take your 1/50th, turn it upside down. And finally, reverse it. Change division to multiplication. And so now, instead of negative 1/25 over 1/50th, we now have negative 1/25 times 50 over 1. For multiplying fractions, much simpler. Just go straight across. So we end up with negative 50 over 25, or simply negative 2. Remember that for elasticities of demand, sign does not matter. The only thing that's going to matter is the magnitude of our elasticity. So our elasticity is going to have an absolute value of 2. Going back to our first table, our computed elasticity was greater than 1, so we know that demand is elastic for these widgets. Man, I remember the last time I bought a widget. My demand was so freaking elastic. Now, there's another rule to keep in mind. That's the relationship between elasticity and total revenue. Studying elasticities is important because it helps us determine pricing. The key concept is that total revenue is the price times the quantity of units sold. So, guys, I promise you don't need to memorize this whole table. I'm just throwing this at you here so that we can see that if demand is elastic, then we're going to have a greater percentage change in quantity than percentage change in price. So even though we're going to lose some money from selling units at a lower price, we'll sell enough extra units to more than make up that loss of revenue. On the other hand, if demand is inelastic, we can raise the price. It'll turn off a couple of buyers, but raising the price a little bit will help us by increasing revenue as long as demand is inelastic. Wait. Let's look at revenue instead of calculating this elasticity. P1 is 198, Q1 is 51, so total revenue at that initial price is $10,098. P2 is 202, Q2 is 49, so total revenue at that second price is $98.98. When we raised the price, revenue decreased. So demand for widgets must be elastic. That was a lot faster. So let's take this whole table and reduce it. If demand is elastic, then price and revenue move in opposite directions. Raising the price lowers revenue, lowering the price raises revenue. If demand is unit elastic, small changes in price, they're not going to matter. So raising or lowering the price won't change our revenue. And finally, if demand is inelastic, price and revenue are going to move in the same direction. So raising the price will raise revenue, and lowering the price will lower revenue. Stop for a minute and think about the question on this final slide. Thanks for listening to the second mini lecture.